All right, let's talk about a piece of tech that is literally everywhere, powering our world from behind the scenes, but most of us never even think about it. We're going to demystify the humble, but honestly, brilliant DC motor.
So think about it for a second. A fan, an elevator, a giant industrial conveyor belt. What could they possibly have in common? They seem totally unrelated. But what if I told you that deep down, they often share the exact same mechanical heart?
And that heart, 9 times out of 10, is the DC shunt motor. Now, the key phrase here is that the windings are connected in parallel. It sounds technical, but that one design choice is what gives this motor its superpower. It keeps a ridiculously constant speed no matter what you throw at it. It's an engine that's just built for stability.
Okay, so how does this unseen workhorse actually get the job done? Let's pop the hood and take a look at the basic physics that makes it all spin. Every DC motor is basically made of these 4 key parts working together. You've got the field windings, which are stationary. Think of that as the outer casing creating a steady magnetic field. Then inside, you have the part that actually spins, the armature. And then you have the really clever bits, the commutator and brushes. They're the go-betweens that get the power to the part that's moving.
The whole thing works because of one beautiful, fundamental principle: electromagnetism. You run an electric current through the armature and boom, it becomes a temporary magnet. That new magnetic field then pushes and pulls against the magnetic field from the stator, and that constant battle, that opposition, is what creates that smooth, powerful rotation. Now this is where it gets really, really cool. As that motor starts spinning faster and faster, it also starts acting like a tiny generator. It creates its own voltage that actually pushes back against the power source. This is the motor's secret weapon for controlling its own speed. The faster it spins, the harder it pushes back, which keeps it from just spinning out of control. It's a self-regulating machine. In this graph right here, this shows you exactly why these motors are so popular. Just look at it. The vertical line is speed, and the bottom line is the load, or how much work it's doing. See how that line is almost perfectly flat? That's the magic. It means whether a conveyor belt is totally empty or piled high with heavy boxes, the motor's speed just doesn't drop. That's the kind of stability industry is built on.
But, every hero has a weakness, right? And this beautiful, elegant design has a built-in catch, a vulnerability that really sets the stage for everything else we're going to talk about.
Yeah, unlike so much of our modern tech, you can't just install a DC motor and then walk away and forget about it for 10 years. They need you. They need a little bit of attention to keep running right. And here's the paradox, the central conflict of the DC motor. The parts that are absolutely essential to making it work, the brushes and commutator that carry the electricity, are also the very parts that are designed to wear out. They're constantly rubbing against each other, creating friction and electrical sparks. It's kind of like the brake pads on your car, right? You absolutely need them, but you also know from day one they're not going to last forever. The good news is when these parts start to go, the motor will give you some pretty clear warning signs. You'll see things like streaks or lines on the commutator. Maybe the brushes will look chipped or even burnt. And a big one is just checking the brush length. If it's less than a third of what it was new, you know you're headed for trouble. So the big question is, how do you prevent a sudden, expensive, catastrophic failure? Well, it all comes down to getting ahead of the problem with a little preventative maintenance. Let's break it down. And lucky for us, the experts have already laid out a roadmap. There's a 10-point check you can do. It's a pretty simple but absolutely vital routine that, if you do it regularly, will dramatically lower the chances of a breakdown and keep that motor humming for years to come. Now, 10 points might sound like a lot, but you can really boil it all down to 4 main jobs. First, you run some electrical tests to make sure the wiring is healthy. Then you do a really close visual inspection of those brushes and the commutator, looking for all those signs of wear we just talked about. And finally, you give the whole system a good, thorough cleaning. And speaking of cleaning, here is a fantastic pro tip. When you're cleaning out all that black dust, use a vacuum. Do not use compressed air, and here's why. That dust, which comes from the carbon brushes, is electrically conductive. If you blast it with compressed air, you can actually force that conductive dust deep into the motor's windings, which can cause a short circuit. You could literally make the problem 100 times worse. And for any of this to be effective, it can't be a once-a-year thing. For equipment that's really critical, this health check needs to happen every single month, or at the absolute bare minimum, once a quarter. Consistency is everything here.
So let's just pull back for a second and wrap up by looking at the big picture. Why does all of this actually matter so much?
Well, taking the time to do these simple checks, the payoff is huge. It's not just about maintenance, it's a strategic move. You're preventing incredibly expensive downtime, you're massively extending the life of the machine, and honestly, most importantly, you're making sure the whole operation is safe for everyone involved.
At the end of the day, understanding and caring for these simple but powerful machines, that's what keeps our industries going. It's what keeps our world moving. It's all about respecting that unseen workhorse. So the next time you see a fan spinning or you ride in an elevator, you'll know the secret workhorse chugging away inside. Which leaves us with just one final thought to chew on. What other technology in your life do you treat as fit and forget that maybe, just maybe, needs a little more of your attention?